Hi, I'm Bob. Welcome back to 5-Minute Econometrics, a program of introducing fundamental econometric concepts, estimation methods, and identification strategies. Today, we will have a look at the overall F-statistic. In the Stata regression results window, we can see the overall F-statistic and its p-value. The overall F-statistic is for the overall significance of the regression. The null hypothesis for the overall F-test is that the parameters of all explanatory variables are zero. It means that the explanatory variables in the model could not explain the variation in the outcome variable at all. All of them should be excluded from the model if the null hypothesis is true. Usually, that is not the case. We often see a large overall F-statistic and a tiny p-value, which implies that the null hypothesis is not true, and at least one of the explanatory variables has explanatory power. For example, in the case of baseball players' salaries, the null hypothesis for overall significance is that the parameters of all 5 explanatory variables are zero. It means none of them affects baseball players' salaries. The overall F-statistic equals 117.06, and its p-value is 0 to 4 decimal places. It is strong evidence against the null hypothesis. It suggests that at least one of the explanatory variables helps to explain baseball players' salaries. We can use the R-squared form to compute the overall F-statistic. From the original model, we can obtain the unrestricted R-squared. The restricted model is the model with only an intercept, and all explanatory variables have been excluded from the equation. Recall that the R-squared is the proportion of the variation in the outcome variable that can be explained by the explanatory variables in the model. Since there is no explanatory variable in the restricted model, the restricted R-squared should be 0. The R-squared form overall F-statistic can be written as follows. The numerator degrees of freedom, Q, is the number of restrictions, which equals the number of explanatory variables, K, for the overall F-test. So we only need to regress the unrestricted model and plug in the unrestricted R-squared to find the overall F-statistic. Then we can use the f-tail function to find its p-value. The results are identical to those in the regression results window. We can also use the residual sum of squares form of the F-statistic to compute it. For the restricted model, there were no explanatory variables, so the residual sum of squares equals the total sum of squares. Because the outcome variable is the same for both the unrestricted model and the restricted model, and the sample size is the same. The total sum of squares will be identical for both models. Therefore, the numerator becomes the explained sum of squares of the unrestricted model. we can obtain the same results using this formula. Today, we have explored the overall F-statistic. We can use either the R-squared form or the residual sum of squares form to compute it. Both methods only require regressing the unrestricted model, that is the original model. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.